The third chapter of AI, A Modern Approach by Stuart Russell and Peter Novick focuses on solving problems using search algorithms. This chapter delves into how intelligent agents can find solutions in environments where the correct sequence of actions need to be determined. First, introduction to problem solving by search. The chapter introduces the idea of problem solving as a fundamental aspect of AI. When an agent does not know what actions to take directly, it must search through possible actions to find a solution. Problem solving in AI involves defining a problem as a search through a state space, where states represents configurations of the world and actions represents transitions between states. The key components of search problem include initial state, the starting point of the problem, actions, set of possible actions that can be taken, transition model, a description of what each action does, mapping from one state and action to a new state, goal test, a way to determine whether a given state is a goal state, path cost, the cost associated with a sequence of actions leading to a solution. The objective is often to find the least cost path to the goal. Second, formulating problems. Russell and Novick emphasize the importance of problem formulation, which involves choosing a suitable representation of the state space and the possible actions. Well-formulated problems can significantly reduce the search space and making finding a solution more efficient. The chapter discusses different examples of problem formulation. Toy problem. These are simple small-scale problems used to illustrate search algorithm. Examples include the 8 puzzle, tic-tac-toe and river crossing problems. Real-world problems. These are larger, more complex problems that are often incurred in practical applications such as route planning, robot navigation, scheduling tasks, and game playing. The authors highlight that the way a problem is formulated can affect the performance of the search algorithm. Therefore, it is important to abstract enough details to make the problem tractable while retaining the critical aspects needed for finding a solution. Third, basic search strategies. The chapter then presents several fundamental search strategies used for problem solving. Uninformed, blind search strategies. These algorithms do not have additional information about states beyond the problem definition. They systematically explore the state space until a solution is found. As BFS explores all nodes at the current level before moving to the next level, it guarantees finding the shortest path in an unweighted graph but can be memory intensive. Depth first search explores as as far as possible along one branch before backtracking. It uses less memory than BFS but may get stuck in loops or miss shorter paths. Depth limited search, a variation of DFS that limits the depth of the search to prevent infinite loops, introduces a limit to the depth path of exploration. Iterative deepening search combines the benefits of BFS and DFS by progressively deepening the depth limit. It finds the shortest path while using less memory. Uniform cost search, a priority based search where nodes are expanded based on the lowest path cost. It is effective for finding the least cost solution when step cost is vary. The authors analyze the strength and weakness of these methods, focusing on aspects such as completeness, whether a solution is guaranteed to be found, time complexity, space complexity, and optimality, whether the solution is the best possible. Fourth, informed heuristic search strategies. In contrast to uninformed searches, informed search use additional knowledge to guide the search process more effectively. The chapter discusses heuristic functions which estimate the cost from a given state to the goal. Heuristic search algorithms include greedy first search, uses the heuristic functions to select the node that appears closest to the goal. It is not guaranteed to find the optimal solution but can be faster than uninformed methods. A-star search combines the path cost and heuristics to estimate the choose the node that minimizes the total estimated cost, sum of the path cost so as far the estimated remaining cost. A star is both complete and optimal if the heuristic function is admissible, never overestimate the true cost. The chapter also introduces the concept of admissible and consistent heuristics. And admissible heuristics never overestimates the true cost to reach the goal, ensuring A-star search remain optimal. A consistent heuristic or monotonic heuristic satisfies a specific inequality that guarantees consistency in the esteemed cost. Fifth, heuristic function. Russell and Norman discuss techniques about designing effective heuristic functions. They explain how heuristics can be derived by simplifying a problem or through methods such as relaxed problem. A problem is relaxed by removing some constraint, allowing for a solution that can serve as an estimate for the original problem. Pattern database. Pre-computed tables that store the exact solution cost for specific subproblems which can be used to generate heuristics. Learning heuristic from experiences. Heuristic values can be learned based on problem solving experiences. Choosing an appropriate heuristic is critical, as well as chosen heuristic can be drastically reduce the search space and the time needed to find the solutions. Sixth, search efficiency. The chapter discusses methods to improve search efficiency and manage memory constraint. Memory bounded search algorithms, such as iterative deepening, simplified memory bounded, which balance well between heuristics and conserving memory. Avoid repeated states. Techniques such as used in hash tables or set to keep track of the explored nodes, which help prevent exploring the same state multiple times, thus reducing time complexity. The authors also cover bidirectional search, which search begins simultaneously from the initial state and the goal state. When the two searches met, a solution is found. This technique can reduce the search space significantly. And here's the conclusion. Chapter 3 provides a thorough introduction to search algorithm in AI, exploring both uninformed and informed methods. It covers different strategies for solving problems, the role of heuristics, and ways to enhance search efficiency. The chapter serves as a foundation for understanding more advanced AI algorithms by establishing fundamental techniques used to solve problems via search, setting the stage for topics like constraint satisfaction, optimization, and game playing covered in later chapters. Thank you.